Okay, my friends, we have 3 steps left, and the one we're about to implement is the confusion matrix, which is a simple 2D matrix, 2 rows, 2 columns, which will show us the number of correct predictions we did in both cases, predicting 0 or 1, and how many incorrect predictions we did in both cases, 0 or 1. Alright, so that will be a nice way to see quickly where we did right and wrong, and also in that same code cell we will compute the accuracy. And now, well, at the end of the previous tutorial, I actually asked you to try to figure it out on your own by looking at the scikit-learn API. So that's exactly what we're going to do first here. I'm going to show you how to navigate it and find the information we want, the tool that we need. So let's go back to the welcoming page, scikit-learn. Then remember you have to go to API here, which contains all the classes and functions from the different modules. And I actually gave you a hint in the previous tutorial. I told you to go to look into a module called metrics. Remember? So we just have to scroll down a bit here and we will find very soon metrics. It's in the alphabetical order, so there it is, metrics. And then it's very well organized. As you can see, you have the regression metrics, in which we already covered the most important ones, and the classification metrics. And here we are of course dealing with classification, therefore you had to look into here, and now we're getting closer, we're getting warmer. What do we see inside? Well, we actually see metrics, confusion matrix, and that's exactly what we'll take in order to build this confusion matrix. Alright, and then what I usually do is simply have a look at one of the examples, because it usually contains the code on how to build such a tool, the confusion matrix, but it usually gives you this example on some random values of dependent variable vectors, that's like ytest, the vector containing the real results, that's ypred containing the vector of predictions, and it tells you how to apply this confusion matrix function onto the vector of real results and the vector of predictions. Okay, so in order to implement this, well, let's just take this so that we can import indeed that confusion matrix, which belongs to the metrics module from the scikit-learn library. So there we go. Let's paste that first. I just copied it. Let's create a new code cell and paste this. So that's how you import the confusion matrix. And then let's grab that other piece of code, this particular line, where indeed we apply the confusion matrix function onto the vectors of predictions and real results. So let's paste this. So you see what I'm trying to do here. I don't do this because I'm lazy. I do this in order to train you to be independent. Whenever you need a new information or a new tool that you need, I'm training you on how to find it in the scikit-learn API. And I will do the same later on when we start working with TensorFlow, in the deep learning part of this course, part 8. But so you see, this is very important. I really want you to be independent and figure things out on your own. And now, inside this confusion matrix function, what do we have to replace? Well, they call the vector here of real results yTrue, but us, since we actually want to distinguish the vector of real results in the training set and the test set, well, we actually called our yTrue vectors, let's say, yTrain for the training set and yTest for the test set. So here, since of course the confusion matrix is usually evaluated on the test set, for new observations, here we have to replace yTrue by yTest, so that we will get indeed the confusion matrix showing the correct predictions and the incorrect predictions for both cases 0 and 1 on the test set. Great, so we will actually put the output of this confusion matrix function applied to ytest and ypred into a new variable which we're going to call cm, which stands for confusion matrix, and which will be exactly the output returned by this confusion matrix function. So there we go. And then we'll add a final print cm in order to print indeed that confusion matrix. Okay, so these are the 3 lines of code that allow indeed to build that confusion matrix and print it. And now remember that I also asked you to compute the accuracy, and well, to do this we just had to do exactly the same as what we just did, to find that information. Actually try to press pause on the video and find it yourself if not already. So we're going to go back to that metrics module, remember the metrics module from the scikit-learn library, and we're going to look back into this classification metrics section to find the accuracy. So according to you, where is it? Well, it's hard to miss it. This is actually the first one, accuracy score, which computes indeed the accuracy classification score, which is just, the rate of correct predictions. So let's do this. Let's click this link and we will get indeed all the documentation on this accuracy score function, which returns the accuracy of your model on whatever set of data, and we'll apply it, of course, to the test set. So first of all, here, as we can see, this accuracy score function belongs, of course, to the same metrics module. So we don't have to take all of this again. We can just take that name of the function here, and I will show you what to do. Here, just next to confusion matrix, you add a comma, and then you can paste this other function you need, which you have to import still from that metrics module from the scikit-learn library. Okay, so now we have it, so now we can use it, and therefore just below we will actually call it, and in order to do this efficiently we can just take the example here and right below we paste it, and we just replace once again yTrue by yTest, so that we can get indeed the accuracy on the test set. Okay, and here we don't have to do a print because this accuracy score will directly return that accuracy, that rate of correct predictions. So there you go, we can just play this cell, run this cell, and here you go, congratulations, you have here the confusion matrix showing that we have indeed 65 correct predictions of the class 0, meaning the customers of the test set who didn't buy the new SUV, then 24 correct predictions of the class 1, meaning correct predictions of the customers who bought the SUV, and then 3 incorrect predictions of the class 1, meaning 3 incorrect predictions of the customers who bought in reality the SUV but were predicted not to, and finally 8 incorrect predictions of the class 0, meaning 8 customers who in reality didn't buy the SUV but were predicted to buy it. Okay, so you see the confusion matrix has no mystery, it's very easy to read, and in a flashlight we can indeed get the main information of our predictions. And finally, that little number that we have here is of course the accuracy, and here we get 0.89, which means that we had 89% of correct predictions in the test set, and actually remember that there are 100 observations in a test set, which means that we had indeed 89 correct predictions. Actually, 65 here plus 24 is equal indeed to 89. All right, but for any size of the test set, this would mean that you had 89% of correct predictions. And that's exactly the accuracy. The accuracy is the rate of correct predictions. All right, so now you know how to, quickly evaluate a classification model. The accuracy is usually the right metric to use when evaluating your classification models. So now you have it in the toolkit. And so here we go for our final step of the journey. We're going to visualize not only the training set results, but also the test set results. And this will be super interesting because we will actually see how the logistic regression classifier was actually trained to classify our customers, our observations, into the 2 different classes, 0 or 1. We will have super nice results showing all the real results in both the training set and the test set, and also the prediction regions, the regions where our predictions are 0 and the other region where the predictions are 1. And you will see that the curve that separates these 2 regions is exactly the classification curve. And you will see that it will be a straight line for linear models and something else than a straight line for nonlinear models. I really can't wait to show you this because you will really see and visualize the difference between linear classification models and nonlinear classification models. So there you go, take a little break now and we'll tackle together this final step to visualize indeed these 2 results. And until then, enjoy machine learning.